Okay, that should be better. It's my first time up here. Hi, everyone. I'm Andrew Shapiro, the Environmental Contamination Administrator in the Health Department. As you know, being at this meeting, you probably know that PFAS are commonly detected in the groundwater of Nantucket, and at some cases at very, very high concentrations. So our health department has a commitment to spread PFAS awareness and promote science-based PFAS education. And so I'm pleased to announce that we have a world-renowned PFAS expert in the house tonight. And I have a few housekeeping items that I'll just share before I introduce our speaker. First, this presentation is being audio and visually recorded. Looks like we have about 28 people online at the moment, which is great. Second, I want to just say that we have 2 more public information sessions upcoming. The next one is December 11th at 5:30 in the same room. We'll be featuring Dr. Tamara James Todd from the Harvard School of Public Health. She'll be doing a deeper dive on PFAS health effects. And then in January, date TBD, we'll have Dr. Rebecca DeVries, who, if you've been to the Board of Health meetings recently, has been presenting on our surface water and foam sampling. She'll be presenting in January for a more detailed dive into that data. So with that, I am pleased to present Dr. Laurel Shader, and I'll just do the obligatory bio for her. Laurel is a senior scientist at Silent Spring Institute, where she studies exposure to PFAS forever chemicals from drinking water, diet, and consumer products, and she studies how PFAS can affect human health. She works with communities to develop research studies and resources to address their concerns about chemical exposures. Dr. Shader leads the Massachusetts PFAS and Your Health study, part of the broader PFAS multi-site study funded by the CDC in impacted communities across the U.S. She has been interviewed by NPR, The Washington Post, and other major news outlets, and testified in front of a Senate subcommittee in December 2024. Before joining Silent Spring, she was a research associate at the Harvard Chan School of Public Health. Dr. Chan earned her master's, Dr. Shader earned her master's and PhD in environmental engineering at the University of California, Berkeley, and it has a bachelor's degree in environmental engineering science from MIT. So with that, I'm pleased to introduce Dr. Laurel Shader. Please take it away.
All right, thank you so much for inviting me, Andrew. Thanks to all of you for braving the cold, windy weather to be here tonight. And yeah, it's great to be on Nantucket. It's my first time being here, so thanks for inviting me. So I appreciate this opportunity to talk with all of you about PFAS, and my guess is if you're here, you know something about them, but talk about how we can be exposed to PFAS and what are things we can do to avoid them. First, I'd like to introduce you to our organization, Silent Spring Institute. We are an independent nonprofit research organization dedicated to understanding links between everyday chemical exposures and women's health with a focus on breast cancer prevention. We were founded over 30 years ago by visionary activists from the Massachusetts Breast Cancer Coalition who were concerned to learn that rates of breast cancer were higher on Cape Cod than other parts of the state and saw the need for more scientific research on how the environment can play a role in women's health. So we are now a leading scientific research organization focused on environmental causes of breast cancer, and we continue to partner closely with Massachusetts Breast Cancer Coalition and other organizations who help to amplify the impact of our work. So our research is pretty multifaceted, but broadly speaking, we focus on identifying toxic chemicals that might play a role in breast cancer. So understanding from previous studies in toxicology, in epidemiology, so lab studies and studies of people, to know what types of chemicals might play a role in breast cancer. We study how we might be exposed to them, and that's where a lot of my work has been on drinking water, on food and consumer products. And then we conduct additional studies to learn how these chemicals can affect our health and applying new methods to assess toxicity of chemicals. And so we go to scientific conferences, we write peer-reviewed journal articles, we're very much in some ways like academic researchers, but we're also very committed to translating that work to have impact and protect people's health. This can be writing tips and creating a smartphone app to help people in their own homes take steps to reduce their exposures. We do outreach to legislators and policymakers to share our scientific knowledge. We write press releases and engage with the media as a way to reach broader audiences. And we help companies who are trying to make a commitment to choose safer alternatives with the broader goal of preventing cancer and other disease. So our team at Silent Spring has been studying emerging drinking water contaminants on Cape Cod since the 1990s as part of this broader question of what might have been contributing to higher breast cancer rates on the Cape. I started working at Silent Spring in 2009, so I picked up the baton from some previous work that had been done on PFAS and septic systems and ponds and groundwater, and the first thing that I worked on at Silent Spring was a study of public and private drinking water wells in 2009 and 2010. And I hadn't even heard of PFAS at that time, but they were among the chemicals that we looked for. One of my colleagues was prescient, I think, in knowing that these were going to be a big concern. And so we were actually the first to find PFAS in drinking water on the Cape. And I guess I've been focused on them ever since. And beyond our research, we also are dedicated to research translation and community engagement. Andrew already read my bio, so I did have the opportunity to speak at a Senate subcommittee hearing. We speak at a lot of community presentations, such as this one. When we, in our research, partner with community organizations to make sure that the work that we're doing is locally relevant and meeting their needs. And they have a lot of knowledge that makes the research better as well. So we look for all different ways that we can translate what we know to broader audiences. So here's our agenda for this evening. Again, my guess is all of you know something about PFAS since you're here, but we'll start off with a PFAS 101. What are these chemicals? Where do they come from? Why are they of such concern? Talk a bit about exposures and health effects. If you want a deeper dive on health effects, there'll be another discussion next month by my colleague, James Todd from Harvard, and she'll talk more about health effects. I'll talk broadly about PFAS in drinking water and some things that I've learned about PFAS in Nantucket drinking water. I'm not the expert on that, so if you have deep dive questions, Andrew or someone else might be able to answer those, but I did learn in preparing for this. I'll talk a little bit about 2 studies that we have underway right now in other parts of Massachusetts related to PFAS, and end with some resources and tips for things that you can do. So I'll only say this once. PFAS stands for per and polyfluoroalkyl substances. It's a class of over 14,000 different chemical structures. They've been also called forever chemicals because it's easier to say, and also because these chemicals are extremely persistent. They're characterized by having carbon-fluorine bonds that are some of the strongest bonds in chemistry. So these are synthetic chemicals, and they just really don't break down. So they move all throughout the globe. They've been found in the blood of polar bears. They've been found in rainwater and ocean water. They aren't necessarily everywhere, but they kind of can show up anywhere because of their persistence and their widespread use. PFAS have been used in consumer products since the 1950s. So if you think of those old commercials for happy housewives with their Teflon pans or Scotch-guarded carpets, these have been in use for a long time. So you might wonder, why are we suddenly hearing about them now, like 70 years after they started to be used? And I think there are a couple of factors. One is that analytical chemistry has improved so that we can actually now find and detect parts per trillion levels of PFAS in drinking water. And that's provided a new lens, and we're now realizing over the past 10 or 15 years that these are really in drinking water all over the place. And I think that's really concerning to people, rightly so, that we have these toxic, persistent chemicals showing up in drinking water. And I think also it's because of the heroic work of many community activists who, upon learning that there's PFAS in their drinking water, have stepped up to ask for water treatment, to ask for blood testing, to ask for health studies, and have really drawn attention to this issue. So if you, after tonight, want to learn more about PFAS, there are a couple of films you could watch. So one is Dark Waters, which is a Hollywood film about a community in West Virginia. There's also a documentary called The Devil We Know. And this is an area that was contaminated by a DuPont plant and a heroic lawyer who fought for justice for the community. And if you're a little more literary in your pursuits, there are 2 books. They both came out this year talking about PFAS in communities and across the country. So those are really good to read as well. So I will not do a deep dive on chemistry tonight, even though I would be happy to. But I do just want to introduce you to some members of the PFAS family tree. So broadly speaking, there are two types of PFAS. So there are non-polymers, which are sort of smaller molecules, and then there are polymers, which are like really long, big molecules that kind of stay embedded in products. And within the non-polymers, if you don't learn any other PFAS tonight, the two that you should know about are PFOS and PFOA. So these are what we call long chain PFAS because they have that long carbon chain at their core. These are what we call legacy PFAS as well. So they used to be manufactured by 3M and DuPont and other chemical manufacturers, and they've been phased out of production, at least in the US and Europe. And in their place, industry, in their infinite wisdom, said, okay, we won't make long chain PFAS anymore, we'll make short chain PFAS and other variations on the chemistry. So these are the types of PFAS that are currently used in products. They're still really persistent. They raise some of the same health concerns, but we've kind of done this regrettable substitution where we've phased out the long chain PFAS and are now using other PFAS. And then polymers, the most notable one is PTFE, which is Teflon, and it's just a long carbon chain with fluorines all around it. So the polymers are molecules that kind of stay embedded in products. These aren't the ones moving around in drinking water or necessarily showing up in people's bodies, but these non-polymers are the ones that are in drinking water and the ones that we do find in people's blood. So PFAS are widely used in consumer products, and you rarely find the word PFAS on a product label, but I bet you have something in your house with Teflon or Scotchgard or Gore-Tex jacket, maybe you use Oral-B Glide dental floss, maybe you have some microwave popcorn bags. It can be hard to know, even for someone who studies them, all the things in your house that might have PFAS. They're also used in waterproof mascara and other cosmetics. They're in floor waxes, they're in paints. So it's not just products that we routinely buy, but also in our building materials. And so it's really hard to avoid PFAS because they're in so many things in our daily lives. So as I said, we started working on PFAS related to drinking water quality, but our work has branched out to also consider exposures from food and food packaging and consumer products. In 2017, we led a study that documented that PFAS were really common in fast food packaging all across the country. We've found that people who ate more fast food or ate more microwave popcorn had higher levels of PFAS in their blood, and also, as well as people who reported using Oral-B Glide dental floss or had Scotch-guarded carpets in their home. We also looked for PFAS in textile products marketed for children and adolescents and found that PFAS were common, particularly in products marketed as being stain resistant or waterproof. So I wanted to give an example of the impact of some of our work, and as you saw, our work has been quoted in Washington Post and other news articles. I don't know if you guys are all fans of The Onion, but it's a satirical online newsletter. And maybe one of my most proud career moments is that our fast food packaging study was covered in The Onion with their humorous take on it, which was gratifying to see. But what was even more impactful was that the state of New York, when they implemented a ban on PFAS in food packaging in 2020, specifically mentioned our paper in the wording of the legislation. And in the kind of work that we do, we often know that our work does have impact, but it's often indirect and takes a long time to see. And so it was really gratifying to see our work being highlighted in this way. So that's a quick overview of what PFAS are and where they come from. So I'd like to talk now a bit about how we can be exposed to PFAS and what are some of the ways that we've learned PFAS can affect our health. So we do know that exposures to PFAS are widespread because PFAS are used in so many products, and they also can accumulate in our bodies. They bind really tightly to the proteins in our blood, and so especially those long chain PFAS can be really difficult for our bodies to excrete. So as a result, testing by the CDC has estimated that over 99% of people in the US have PFAS in our blood. And that's based on a representative sampling that they do every 2 years on several thousand people in the US. This is due in part to the fact that, especially for the long chain PFAS, they can stay in our bodies for years. So even if we stop being exposed to them, it takes years for the amount in our blood to go down by half, and that same amount of time to go down to a quarter. Those newer PFAS, the short chain and the other current use PFAS, industry likes to mention that they don't stay in our bodies as long, and that's true. They stay in our bodies for weeks to months, which is still not really quick. But just because they don't stay in our bodies for years doesn't mean they aren't harmful, because we do get exposed to them all the time because they're in so many products. And then for many PFAS, we're actually not sure how long they can stay in our bodies. If you're wondering who's likely to have the highest levels of PFAS in their blood, certainly workers at a fluoropolymer manufacturing plant, so where these chemicals are made, can have quite high levels in their blood. Firefighters can have elevated exposures related to their use of a certain class of firefighting foam called AFFF, as well as the protective turnout gear that has a protective layer that typically has contained PFAS. I'll mention the policy changes in Massachusetts in a little bit. In general, older adults tend to have higher levels than younger adults because these chemicals can accumulate in our blood over time. And men typically have higher levels than women, and there's a couple of reasons for that. So I mentioned that PFAS bind really tightly to the proteins in our blood. So women can lose some of the PFAS in their bodies through menstruation. Unfortunately, we also pass PFAS along to the next generation through pregnancy and breastfeeding. So we do see that resulting decline in women's bodies, but unfortunately that means that babies are born already being exposed to PFAS. So in terms of how we can be exposed to PFAS, so these are not naturally occurring chemicals. They all come from industry. They can get out into the environment in a number of different ways. I'll talk about that a little bit more in a minute. One of the ways is through AFFF, which is aqueous film forming foam. This is a type of firefighting foam used for fighting liquid fuel fires. So say if an airplane catches on fire or oil tanker truck or something rolls over, it's very good for fighting fires with flammable fuels. So they tend to be pollutants at military bases, airports, and other fire training areas. So once PFAS get out into the environment from industry or from firefighting foams or from waste streams, we can be exposed to them through our drinking water. We'll talk more about that in a minute. Through food, so the plants, the animals that we eat can absorb PFAS from their surroundings, or they can accumulate up the food chain, and then we can be exposed through consumer products as well. And as I said, infants can be exposed in utero as well as through breast milk. So with respect to consumer products, you might wonder, well, if I have, something in my Gore-Tex jacket, is that really going to end up in my body? And we do know that chemicals and products don't necessarily stay in the products. And so many consumer product chemicals can migrate out of the products and end up in air or in the dust in our homes. We don't really think of dust as with respect to chemicals usually, but there are many consumer product chemicals that can accumulate in the dust in our homes. And that can lead to exposures in a couple of different ways. So we all, without meaning to, inhale or ingest a little bit of dust every day. So that's one way that we can be exposed. Certain PFAS are actually volatile, so they can end up kind of in the air that we breathe in. And then we can also be exposed through absorption through our skin. There's not a lot of evidence yet about the extent of dermal absorption, but that is a way that it's thought that people can be exposed. And with respect to PFAS, our findings by Silent Spring Institute and other researchers has shown that the presence of PFAS in consumer products and furnishings does lead to higher levels of PFAS in people's blood. Children and infants can be especially exposed to PFAS and can be especially vulnerable to their harmful effects. So children drink more water, breathe more air, and eat more food per unit body weight than adults. If you've had kids, you know that they spend a lot of time near the ground and a lot of time with their hands in their mouth. So they do tend to have higher chemical exposures than adults. And then their developing bodies are more sensitive to the harmful effects of these chemicals. So I'll talk a little bit about what we know so far about how PFAS can affect our health. But I wanted to start with how do we learn in general about how toxic chemicals can affect us. And there's kind of three different types of studies that I'll talk about. So one are epidemiological studies. So these are studies in people who've been exposed to a chemical. And in the case of PFAS, that's all of us because we've all been exposed. And the benefits of epidemiological studies are that they're done in people, so the results are relevant to people. And they account for our human biology and physiology. But in some cases, it can be difficult. You can say, oh, we see this health effect in people who have higher levels of this chemical, but you want to make sure that there's not some other factor. Is there something about the people who had higher exposures, some other thing that maybe is causing that health effect? And these studies can take a long time. And often if we're wanting to have a kind of precautionary approach, you don't want to wait till you've had a whole population of people exposed before you learn about whether they're harmful. So to complement epidemiological studies, researchers also do toxicological studies. So these are typically done in mice or rats in the lab. And they offer some advantages, right? So you can expose one group of rats to a chemical and the other group of rats doesn't have that chemical exposure. And if you see a change in them, you can be pretty sure it's related to that one specific chemical. It's easier to study multiple generations, and we think a lot about how there can be intergenerational effects of chemicals. Of course, we're different than rodents, and so there can be some physiological differences between the laboratory animals and people. And they do still take a long time, maybe not as long as an epidemiological study, but they're, take maybe months or years to do. And then the third type that I'll mention are what we call in vitro or lab-based studies. So these are where maybe you have a plate in the lab with little components, and you put cells in, or you're able to sort of model how PFAS can bind to receptors in cells. And so that's great. You can do lots of experiments really quickly, but there's sort of an extra step there when we're thinking about does the same thing happen in our bodies? So what's really helpful is to have kind of all three lines of evidence, because if we say, hey, we're looking at people who've been exposed, we see this health effect, we see the same thing happen in laboratory animals, and then we do some cell-based studies and we maybe think of a biological effect, that gives us more confidence that we're really seeing that linkage. So it's really combining evidence from multiple types of studies that provides the best sense for us of how PFAS and other toxic chemicals can affect our health. So what do we know about how PFAS can affect our health? I'd say that much of what we've learned so far is really on those long chain PFAS, the ones that have accumulated in our blood and the ones that we've been studying for the longest amounts of time. There's emerging evidence for short chain and some of the current use PFAS that they cause many of the same types of health effects, but then there are many others that haven't yet been studied. So far from what we've learned, we've seen that the PFAS can really affect many different parts of our body. So they've been associated with increased cholesterol and obesity. So they can affect lipids and metabolism in our body. One of the effects most consistently linked to PFAS exposure are immune effects. There are a series of studies in the Faroe Islands, so in the North Atlantic, showing that kids with higher PFAS in their blood produce fewer antibodies in response to routine vaccinations. And the same kind of effect is actually seen in laboratory animals where they look at antibody responses. And so that strengthens our confidence in terms of PFAS being immune suppressive. PFAS can lead to altered thyroid hormone levels, reproductive effects, developmental effects such as small decreases in birth weight or changes in bone density. As a breast cancer organization, we're concerned by studies showing that PFAS can impair mammary gland development in laboratory animals. And higher levels of PFAS exposure have been linked to certain types of cancer, such as kidney, testicular, and prostate cancer. And to sum it up, the former head of the National Institute of Environmental Health Sciences said, not only do we all have PFAS in our bodies, but we also know that PFAS affects almost every organ system. There have been also a number of studies in children as well. This was from a review study of 60 different studies on kids showing some of these same effects in kids: elevated cholesterol, immune suppression, asthma, reduced kidney function, changes in thyroid and sex hormone levels, and delayed menarche, which is the age of first menstruation. So that's kind of a summary of some of what we know about health effects. And again, if you want to learn a deeper dive, I hope you'll come to next month's meeting. And I wanted to kind of wrap up this section with an important point. So I've been to other community meetings and heard people say, I thought these are forever chemicals, so I think that means that they stay in our bodies forever. And those long-chain PFAS do stick around in our bodies for a long amount of time. But it is important to know that if we stop exposures, that the levels in our bodies do go down. And so this is data from that same CDC testing that I mentioned earlier. And what this shows is that after industry started to phase out long-chain PFAS in the early 2000s, that the levels of these PFAS in people's blood have gone down. So it is important to know that. It does take a while for these long-chain ones that have a long residence time in our bodies, but it shows that when we reduce exposures, that people's levels in their blood do go down. But we don't have the kind of same type of information for the newer PFAS that are now used in consumer products. They don't tend to persist in our blood. They don't bind to proteins quite as much. So we don't have as much information about levels of PFAS for those short chain and other current use PFAS. But where it's likely that people are being exposed to them more and more because industry has switched from using the long chain to these shorter chain PFAS. And so the way that I think about it is sort of like a pie where we get exposed to PFAS, maybe from drinking water, maybe from food and food packaging, and from consumer products. And this pie might look a little bit different if you're in a community that has high drinking water contamination. That blue part of the pie might be dominant. If your drinking water doesn't really have much PFAS, it's thought that food is probably your largest source of exposure. But maybe consumer products are contributing to that as well. And maybe the answer depends a little bit if you're talking about long-chain PFAS that can accumulate in fish. Maybe we continue to be exposed to them for a longer amount of time, whereas consumer product exposures better reflect what's actually being added to products now. All right, so now we're going to switch to one of those pieces of the pie and focus on drinking water. So I've talked a little bit about this already, but if we think about how do PFAS get into water in the first place, I'd say there's sort of two tiers in terms of the extent of contamination from these different types of sources. So I mentioned aqueous film-forming foam, which again is found in groundwater near a lot of airports, military bases, and fire training areas. I know it's an issue in the groundwater near the airport here on Nantucket. In other parts of the country, fluoropolymer production facilities, so the DuPonts, the 3Ms, the places where these chemicals are manufactured, as well as places like Merrimack, New Hampshire, that had a St. Gobain plant that didn't manufacture PFAS, but it made a lot of Teflon-coated products. And so the areas around those types of facilities tend to be where we see the highest levels of contamination, but they tend to be sort of less frequent than these other sources. So wastewater treatment plants, septic systems, landfills, and places where sludge or biosolids from wastewater treatment plants has been applied to land. And these are likely to be sources of contamination in many more areas, but the extent of the contamination is not quite as severe. So sort of lower levels, but in more places. The Environmental Working Group has estimated that 200 million Americans have PFAS in their drinking water. And this is a map created by our colleagues at Northeastern University. They've compiled information about known contamination sources and likely contamination sources across the country. And they've counted about 3,000 known contamination sites and something like 30,000 potential sites that haven't necessarily been tested, but are places where PFAS might be contaminant. So you might say, well, what's anyone doing about this? Are PFAS being regulated in drinking water? So when I started working on PFAS in 2009, EPA had just issued some drinking water guidelines. So these weren't enforceable standards yet, but they had started to recognize that there were communities that were having to deal with PFAS, and they came out with advisories of 400 and 200 parts per trillion, or PPT, for PFAS and PFOA. Fast forward a few years, 2016, they issued an updated guidance of 70 parts per trillion for the two combined, so that's sort of an order of magnitude lower. And then in 2022, they issued guidelines of 0.004 and 0.02, so orders of magnitude lower than really most labs can even measure. But it was really a strong reflection of the emerging science that PFAS can affect our health, even at very low levels of exposure. So these were all non-enforceable guidelines. EPA has to go through a really extended process before they're able to set enforceable drinking water standards like we have for lead or nitrate or arsenic or things that we've known and regulated for many decades. But finally last year, they issued enforceable drinking water standards, which are known as maximum contaminant levels of 4 parts per trillion for PFAS and PFOA. So that's quite a long ways coming down from 400 and 200 15 years ago. You might wonder, why are these levels higher than the guidelines they'd issued a couple of years before that? And the reason for that is that when they issue a standard, this is something that water suppliers have to meet, it has to be at a level that can be regularly and easily measured, has to be achievable with treatment, and they have to do a cost-benefit analysis. So inevitably, the standard is somewhat higher because they take those other things into account and not just the health information. So this was a really important step forward from the perspective of public health researchers and from communities. And in addition to this standard, which I think, I'm not a policy expert, but I think this was kind of expected that they were going to set strict PFAS and PFOA standards. They also issued standards for 4 additional PFAS. So these 3 were going to be regulated at 10 parts per trillion, and then they had a combination standard called a hazard index for those 3 plus a 4th. And so they also said that drinking water supplies would have 5 years to come into compliance, and so that they were going to have until 2029 to do all the testing, and then for water supplies that exceeded these standards to put in place treatment or other mitigation measures. Things have changed a little bit since last year. So unfortunately, these standards are in the process of being rolled back or delayed. So for the PFAS, beyond PFAS and PFOA, those 4 standards, unfortunately, are being rolled back. I am encouraged to see that the PFAS and PFOA standards, they didn't change the numbers. Those are still going to be the standards. And I think there aren't that many places that would have exceeded the other standards but don't exceed the PFAS and PFOA standards. So this is still a really important step forward for most water supplies that have PFAS contamination. They did delay things a bit, so instead of having until 2029, water supplies now have until 2031 to meet the standards. And I'm very sympathetic to the challenges and the costs of putting in place treatment for water systems, especially in small communities. It's a high cost per person for water systems that have to put in place treatment. But I would love to see water systems having more support to help them meet the standard rather than kicking the can down the road a little bit. These are chemicals that we know stay in our bodies for years, and so by delaying the implementation, it means that people will continue to be exposed for longer than they needed to be. So it took the EPA a long time, like I said, to put these standards in place. And in the meantime, a number of states put in place their own standards, which are enforceable or in some cases non-enforceable guidelines. So 24 states and 1 territory had put in place something that was stricter than what the EPA had before the standards last year, including Massachusetts. So in 2020, so 5 years before the EPA standard, Massachusetts established a maximum contaminant level for 6 PFAS chemicals that they call the PFAS 6, and they set that at 20 parts per trillion. So you can see there's kind of different approaches. EPA had some standards that were for 1 chemical at a time, as well as a combination standard, and Massachusetts opted for this combination. And so this means that public water supplies in Massachusetts for years have already had to be testing for PFAS and taking steps to mitigate where needed. And if you wonder, are these the same 6 as the EPA 6? The answer is no, because nothing is quite easy with PFAS. 4 of these are the same, and then there are 2 that Massachusetts regulates that EPA didn't propose to regulate, and then vice versa. EPA had 2 additional ones that they were planning to regulate that aren't being regulated here in Massachusetts. So, like I said, water supplies have been testing for PFAS in Massachusetts. There are 1,400 public water systems in Massachusetts, and of these, 173 of them, so about 12%, have had at least 1 sample show up above the 20 part per trillion standard. Some of these, or many of these, are municipal water supplies, so a water system that serves a whole town. But some of them are smaller public water systems. They might serve a school or a condo or even a restaurant. And if you want to learn more about the water data that are out there, the state has this really cool interactive GIS-based tool where you can look and see what's up with your water system. For Nantucket, there are no exceedances that they have here of the standard, which is great to see. But you might want to know a little bit more about what has been found for the public water wells here in Nantucket. Again, I'm not an expert on Nantucket. I just learned about it this weekend, so there are other people here who might know more. But from what I've learned so far, there are 7 municipal wells serving the residents here in Nantucket. And there are sort of 2 parts of the aquifer. So the aquifer is the groundwater, and some pull from the more shallow aquifer, which is more vulnerable to pollution. And then there's a deeper aquifer where there's more of a confining layer, or kind of a barrier that serves as a bit of a protection from pollution. And so in terms of the impacts, there's kind of a range. So there's one well that was actually shut off in late 2022 because there were PFAS detected there. And in the meantime, those levels have gone up to 55.5 parts per trillion. But this well has not been, there hasn't been water from this well going into the distribution system for almost 3 years. So that's why it's not showing up, I think, on the DEP map of places that have exceeded the standard. And then for the other 6 wells, some of them have no PFAS detected, at least for the ones that are being tested for, and then others do have some detectable levels. So what about private wells? So a lot of people here are served by private wells. So across Massachusetts, 500,000 residents have a private well, and here on Nantucket, there are about 4,000 private wells. So what do we know about PFAS in Nantucket private wells? So this is a statewide map that comes from testing led by the Massachusetts Department of Environmental Protection, Mass DEP, and UMass Amherst. And they aimed to collect about 40 or 50 water samples from private wells in 80 towns across the Commonwealth. And they focused on towns where at least 60% of residents were served by a private well. And so we can see here, there's kind of different color coding. The orange and the red shows the water, that shows the towns where the highest maximum concentrations were found. And so you can see it's kind of scattered. There are some places with really high levels, and then some with kind of lower levels. But we'll focus here on Nantucket. So Nantucket was one of the towns that took part in that testing. And what we learned from the DEP testing. So there were 41 private wells that were tested. I learned that there was quite an enthusiastic outpouring from the community, thanks to the Nantucket PFAS Action Group and a lot of awareness raised about the testing. But only 40 could be tested. The highest level that was found in that testing was 51 parts per trillion, and about 12% of the wells exceeded the state standard. And then about 2/3 didn't have any detections at all. So it's kind of like one set of data. And I think it's not uncommon to kind of have this range of within the same town, some wells that have none and some wells that have levels above the state standard. And in follow-up, there's been more recent testing of nearly 500 wells, and I guess there's other wells that aren't included in this. This is from the Nantucket town website, which is, I found, very informative. So if you want to learn more, you could look there. From this testing, again, about 10% of the wells were found to exceed the state standard. And there's kind of different areas of town. And if you have questions about what's known about where those are coming from, maybe Andrew can answer those questions. Including 12 wells that were over 90 parts per trillion. So concerningly, those are considered to be an imminent hazard. And the highest level, I was kind of surprised to see, was so high at 787 parts per trillion. So that's really quite high. And then there were overall about 40% of the wells did have PFAS detected and about 60% did not. So if you are not one of the people that had your well tested, you might say, oh, I'm curious to know if my well has PFAS. And in terms of the the patterns or our ability to predict. I think one of the things that's challenging about PFAS is that you can have houses kind of next to each other, and one might have a high level of PFAS and the house next door might have non-detect. And I think some of that challenge is that there can be plumes or sort of, an area in the groundwater where the levels of PFAS are high, but that's kind of like a layer of it. And so a private well is like kind of sticking a straw in the ground. And so it might be that one person's straw is underneath that plume of contaminants and someone else's might be above it. Someone else might be right in the middle of it. So groundwater is kind of three-dimensional in a way that's kind of hard to predict. So the best way to know if your water has PFAS is to test for it. We always tell people, when possible, to work with a state-certified laboratory. And so the Barnstable County Lab is now state certified to test for PFAS. And so through the Health and Human Services Department here, there's a way to get your water tested for PFAS only on Tuesday mornings. Yeah, okay. And so it's, it's not super cheap. It's $265 per sample, but you do get tested for 16 PFAS? 18. And the lab does other routine tests as well. So I would take a little side note here and say, if you have a private well, you are responsible for monitoring your own water quality. From our work on the Cape, talking to people who have signed up for our well water testing program, they say, oh, last time I got my water tested was maybe 10 or 20 years ago. You really want to be monitoring your water quality more frequently than that. So a reminder that the county lab tests for other things as well. This was the Barnstable County recommendations. Annually, you should be testing for coliform bacteria, pH, nitrate, some other water quality metrics, and every 3 years, some metals, volatile organic compounds, and then some other ones that they recommend every 10 years. I also learned that Nantucket was the first town in the Commonwealth to require PFAS testing for private wells at the time of property transfer. So that's kind of cool. I was talking to someone from Martha's Vineyard and they didn't even know if that was possible. I said, well, yeah, Nantucket's done it. So let's say you get your water tested and you do find PFAS to be elevated and you want to learn about water filtration. This is a question that I often get from folks who are concerned about water quality. So I don't recommend specific products by name, but just I want to provide you with some information if that is a path that you want to pursue. So I'd say the first thing is always to learn about what's in your water. So get your water tested, see what contaminants are an issue. If you have high nitrate in your water, then you want to look into a different type of treatment than if you have high PFAS in your water. And there's not one filter that gets out everything. So it's important to know first what you're trying to get out of your water. And with any filter, it's important to maintain as recommended. So if it's something that has a filter, make sure you're changing it out. Or if it's a whole house filter and you need someone to come and do the maintenance for you, it's important to do that. Because if you have a filter and it's filtering out the chemicals and then you leave it on for too long, those can actually start coming off of the filter and end up in your water. So it is important to maintain them as recommended. I also, in general, point people to home filtration rather than bottled water. And this is kind of a bigger sustainability issue in terms of like water is heavy, so it takes a lot of energy to move it around. It's usually in plastic. Plastic is problematic in a lot of ways. It can release chemicals into the water. It's made from petroleum. So in general, I try to point people to testing and treating water rather than going the route of bottled water. I did learn, though, in Massachusetts that water bottlers are required to meet state and federal standards, including the PFAS standard. In general, bottled water is regulated by FDA instead of EPA because it's considered food, and it's supposed to meet all the EPA standards, but there isn't in general as much testing or enforcement. But here in Massachusetts, there is oversight of PFAS in bottled water. So in terms of home treatment, there's sort of two main types when we think about where the filters are located. So point of use filters are ones that are kind of right where you're using the water. So something that's like a filter pitcher or maybe an under the sink filter or something on your countertop. That's considered point of use. By contrast, point of entry treats all the water coming into your home. So I know a lot of people have a whole house treatment system for acid neutralization to adjust the pH. When it's acidic, you don't want acidic water going through your metal pipes. And so that's sort of like one big picture question, is whether it's a treatment system that's just at the point of use or for the whole house. If you are specifically focused on removing PFAS from drinking water, you have a couple of options. So one are activated carbon filters. These could be filter pitchers, with the little kind of pieces of charcoal that you can see. That's granular activated carbon. There are also solid carbon block filters that you might have under your sink. Activated carbon in general is very effective for PFAS, PFOA, and the other long chain PFAS. Short chain PFAS tend not to be as well removed with a carbon filter, especially over the lifetime of a filter. I've learned more recently about ion exchange filters. I used to think of these being more for municipal or town water filtration, but ion exchange is also an option for home filtration. It's more expensive than activated carbon. It is also effective for long chain PFAS. I think it also has the same challenge of not being as effective for the short chain PFAS over the lifetime of the filter. And then there's reverse osmosis. So this is very effective for both short and long chain PFAS. It does have some downsides. So basically, if you have an activated carbon filter or ion exchange, what happens is you put water in and it kind of goes through some sort of a filter, the PFAS stick, and then the water comes out the bottom of the filter. With reverse osmosis, what happens is you have your water going into the system, and basically it's pushing water through a membrane, and you're trying to have clean water without the PFAS go through the membrane, and then that's what you end up drinking. So the downside is that for every gallon of water that you kind of are able to squeeze through your membrane, you have about 3 or 4 gallons of wastewater that are kind of a byproduct of that. And so as a result, according to state Title V, RO systems are not supposed to discharge into septic systems. And it's not my area of expertise exactly, but I think the reason for that is that you have a certain size septic system based on how big your house is. And if you suddenly are putting in an RO system and you have all this extra wastewater, it kind of throws off the water balance in your septic system. So that's just something to know. And then there are rules about where the RO discharge can go depending on the PFAS levels in the groundwater. We can get into that detail if someone has a question about it. In general, if you're looking for a water filter, it's a good idea to get one that has some sort of a third-party certification. So you don't just have to take the manufacturer's word for it that their filter is good for removing PFAS. You want to look for filters that have had some sort of oversight. And so the National Sanitation Foundation, or NSF, has certifications for filters, and they have some different standards here, depending on if it's for activated carbon or for reverse osmosis. Again, I'll reiterate that it's important to follow the manufacturer's recommendations for maintenance and changing out filters. All right, so that was a quick overview of PFAS in drinking water, and people might have questions that we can talk about after the presentation. I wanted to tell you a little bit about 2 studies that we currently have underway here in Massachusetts. One is for a project called STEEP, which is Sources, Transport, Exposure, and Effects of PFAS. This is led by University of Rhode Island, and Silent Spring and Harvard are also part of the study. There are a bunch of components to STEEP, but the part that I'll tell you about is our private well study, where we've tested about 150 wells in 15 towns throughout Cape Cod. I know Nantucket is not the Cape, so I won't get into the details of it, but I wanted to share just a couple of high-level findings. One pattern that we've noticed is that we see a higher percent of wells with detectable PFAS on the upper and the mid-Cape compared to the lower and the outer Cape. And the reason for that, we think, is that those parts of the Cape are more developed. And so we generally see that where there's more development, more impact on land, there's also more impact in terms of water quality. One of our other kind of hypotheses is that in many parts of the Cape, we think that PFAS are getting into groundwater from septic systems. So when we have products in our home with PFAS, it's inevitable that our wastewater is going to have PFAS as well. If we mop our floors, picking up fibers from our, our couches or our carpets, or maybe we're washing cookware that has PFAS in it. So wastewater tends to have PFAS in it, and wastewater has nitrate. And on the Cape, maybe here as well, the largest source of nitrate is from septic systems. And so we do see, on average, that wells with higher levels of nitrate, again, this is a likely marker of septic system impact, tend to have higher levels of the PFAS-6. And then in terms of other things that are correlated with PFAS, because we're trying to figure out what are some other markers that we can use if we want to prioritize which wells are most likely to have PFAS, because it may not be feasible, to test everyone's well. We also see that boron is a marker of PFAS as well. So boron is used in borax and other soaps. It's another wastewater marker. This is maybe a little bit more for research studies. I don't think there are a lot of commercial labs that offer testing for acesulfame, but it's an artificial sweetener. And we did see in our earlier study in 2011 that wells with higher levels of this artificial sweetener had PFAS as well. Again, consistent with the idea that septic systems are a source. And then we see an inverse relationship with well depth. And this we also expected to see. In general, shallower wells are more vulnerable to pollution. There's sort of less distance for water to travel from a pollution source before getting to that well. And so we do see deeper wells tend to have lower levels of PFAS. The other study that I wanted to tell you about is called the multi-site study. And I'm an environmental engineer and chemist by training, so it's been a learning curve for me to be leading an epidemiological study. But it's a really important and visible study that's taking place here in Massachusetts and in 7 other states across the country. So the vision or the big goal for this multi-site study is to include people in communities where there's been PFAS drinking water contamination. And it's an opportunity to learn from those past exposures, to learn more about how PFAS chemicals can affect our health. So the study is being led by CDC, so the Centers for Disease Control and Prevention, and their sister agency, the Agency for Toxic Substances and Disease Registry, or ATSDR. And so CDC and ATSDR are funding research teams in 7, ATSDR is leading one of these, so 7 additional states, and recruiting people who live in communities with a history of water contamination. So Silent Spring Institute is actually leading one of these studies here in Massachusetts, and Rebecca, who's going to be speaking in January, is part of our multi-site team as well from Eastern Research Group. And so our study is based in 2 communities here in Massachusetts, so in Hyannis, which used to have higher levels of PFAS than any other public water supply in Massachusetts, and in the town of Ayer, west of Boston. And this is an area that had more moderate contamination of the public water supply. Ayer is located right near the former Fort Devens military base. And so our partners are from Eastern Research Group and from Harvard, and then we have local community partners on the Cape and in Ayer. And I won't go into all the details of it. If you're curious to learn more, I'm happy to talk about it. But big picture, we recruited 700 adults and 100 children to be part of our study. We set up temporary clinics in both of our communities where residents could come. We collected their height, weight, blood pressure, blood and urine samples that we tested for PFAS and markers of health effects. We had them fill out questionnaires about where they lived over time, their health, and about their water consumption. And then for kids, we also administered a series of neurobehavioral tests so that we could learn more about whether PFAS affect children's brain development. So our data collection extended from late 2021 through September of 2023, and we are actively analyzing all of those results to make relationships try to understand the relationships between PFAS exposures and a range of health effects. And while I said at the beginning that there's a lot that we've already learned about how PFAS can affect our health, there are things that we still need to know more about. We are learning more about how different mixtures of PFAS can affect our health. We'll be able to learn more about how the timing of exposure matters. And by including both children and adults, we'll really learn more about how these chemicals can affect our health over the lifespan. So far, we've been able to analyze the results of the PFAS blood tests. What we've seen so far is that, not unexpectedly, the levels of PFAS in our participants from Hyannis were higher than in Ayer, consistent with the higher drinking water concentrations and also higher than the general US population. For PFHXS, which is one of those long-chain PFAS that stays in our body really a long time and is associated with firefighting foams, we saw the median in Hyannis was 3.5 times higher than the general population. And we saw higher levels for PFAS as well. So that's just to give you a flavor of what we're seeing with the results so far. If you're curious to learn more about the study, there's a paper that was published earlier this year that presented the results of blood testing across all 8 states in the study and kind of gives you a roadmap for where the study is going to be headed. So here's a QR code so you can look at the initial results. What we're showing here are how the results from all the sites in the study in green compared to the general US population in the gold bars and to each of the individual states. And here in Massachusetts, our levels were higher than some of the other communities and then lower than others. And there were certainly other communities that had even more severe water contamination over time. I'll also add that for the multi-site study, some of the sites were impacted by firefighting foam, but some were impacted by Teflon manufacturing or different types of pollution sources. And so that's reflected in some sites being high in one PFAS chemical, but not necessarily all that high in others. All right, so I know it's late in the evening, so I'm kind of coming down the home stretch here, and I wanted to share some resources for those of you who might want to learn more about PFAS and some things that we can do. Sometimes it feels kind of heavy and depressing to learn about all these chemicals that are harmful and in all of our bodies and in so many products. But I have been really encouraged by the amount of change that's happening at the federal level and at the state level. And there are things that all of us can do in our communities. So a resource that I really hope that you'll check out is the PFAS Exchange. The PFAS Exchange is an online resource center that we developed initially with impacted communities in mind. But also we have resources for clinicians and firefighters and water utilities. We have fact sheets. We have a data interpretation tool to help people who've gotten their water or their blood tested make better sense of their results. And the Connecting Communities map that I showed you earlier from our partners at Northeastern University. So I'll walk you through a couple of the features of the Exchange. And we just launched a new version of it a couple of weeks ago. So if you looked at it a few months ago, come and check it out because we have new features and a new look and feel to it. So the What's My Exposure tool lets people who've had their water or blood tested enter their results on our page, input page here. And then in real time, you can get graphs and text to help you interpret your results. Because when you get a result from a lab, you see a lot of letters. It says like PFOS and PFNA and PFHXS. It can be kind of hard to interpret if you're not thinking about PFAS all the time. And so what this helps you visualize is how your levels compare to the general population or to water systems across the country more broadly, and it compares you to any relevant guidelines or benchmarks. You can also get a report which you can download or share with others. It has information. The resolution on this screen is not that great. But you can see drinking water regulations. You can learn about PFAS levels in other communities if you've had blood testing. You can learn about how you get exposed to PFAS and things you can do to reduce your exposure, and other ways that you can use your results to, say, improve your clinical care by sharing your results with your primary care physician. We often hear from impacted community members that they express frustration because their doctors don't necessarily know that much about PFAS, and sometimes community members are the ones educating their doctors about what these results mean. And so to address this need, we've developed resources for clinicians, including a continuing medical education course that actually grew out of an idea here in Nantucket. So I don't know if you all know Aisha Khan from the Nantucket PFAS Action Group, but our she's here. Our PFAS REACH team, this is one of our NIH-funded research studies, was talking to Aisha about this challenge of educating clinicians, and we had a vision of just, I think it started as we were planning a webinar just for doctors here on Nantucket. And so it really grew into something much broader. So it's now a continuing medical education course that anyone in the country, I guess anywhere in the world, can take for credit. And the vision is to, and the goal is to bring together public health researchers, clinical or clinicians who were very much involved with the development of the course, and community partners, including Nantucket's own Nate Barber as a community member. And the course is available just on YouTube if you want to access the content, or through Michigan State University, clinicians can get a continuing medical education course. And so it covers topics like PFAS blood testing, it covers medical screening. So the idea is that if you have a patient who you know has elevated PFAS exposures, there's not much you can do to kind of change that past exposure, but we know a lot of the types of health effects associated with PFAS exposures. And so there are certain tests, medical screenings or blood tests that a clinician might want to run for someone who they know has high PFAS exposures. And so working with the clinicians on our team, we've developed guidance about different screenings that might be appropriate for adults or children who have elevated exposures. We often also hear that people in impacted communities want access to PFAS blood testing. So because PFAS do stay in our bodies for extended amounts of time, we can measure the amount of PFAS in our blood, and it can provide some indication about the extent of exposure. There are often barriers to accessing this type of test because insurance doesn't always cover the cost of tests. And clinicians might be reluctant to offer a test if they're not sure how to interpret the results. And so we provide information on the PFAS exchange about how to access these tests, what the benefits are, what some of the limitations are. And we have an interactive tool or a spreadsheet where you can compare different labs that offer different types of tests, either in a clinical setting or even a home-based test as well. And I'll also point you in the direction of Aisha if she works in a doctor's office, Dr. Lepre, thank you for coming. And he's been able to offer PFAS blood testing and can provide advice for other clinicians who are able to offer this type of testing for their patients. We also have resources on our exchange for water and wastewater utilities and for firefighters as well. And so you might, those of you who know Aisha know her husband, Nate Barber, who's a firefighter here on Nantucket. If you just can't get enough PFAS webinars or information, there's another series for the STEEP project. We've been having roughly monthly webinars on PFAS as part of our STEEP team. And the vision for the webinars is to combine researchers from our STEEP team with community voices from the Cape, and to share what might be applicable for other places as well. So some of the past webinars have focused on exposures from consumer products, bioaccumulation in fish, PFAS in drinking water, as well as some perspectives from our work with the Mashpee Wampanoag tribe. And we have another webinar coming up in December that's going to focus on PFAS health effects. And we have all the archived recordings on our website. And then as we think about, okay, so we've learned a lot about PFAS being harmful, and there are ways that we can reduce our exposure and our reliance on these toxic chemicals. And it can feel a little overwhelming because they're in so many things, but this essential uses framework I feel like is a really helpful kind of starting point. And so this was a paper that came out in 2019, but this framework was actually developed as part of the Montreal Protocol back in the 1970s when people were coming together to figure out how to avoid CFCs and ozone depletion. And so what the essential uses framework does is kind of break the uses of PFAS down into 3 groups. So the first group is called non-essential uses. So these are uses that are not essential for health or safety. They're sort of like the nice to haves. So some people really feel connected to their Oral-B Glide dental floss, but it is not actually essential to have that type of floss specifically. There are many other types of dental floss that don't contain PFAS. Another example might be PFAS in food packaging, because we know there's a lot of food packaging that doesn't contain PFAS. So those are kind of the non-essential uses. We don't really need it, and we have maybe alternatives to use instead. Then there's another class that they call substitutable. So something like firefighting foam is a good example. Where this is a really important use, we want to have firefighting foams that are effective and safe. And so fortunately, right now, there are alternatives that are fluorine-free foams that are effective in the same way that those AFFF foams are effective for fighting fires, but without the use of PFAS. And so that's an example of substitutable where it is an important use, but we do have a good alternative. And then the last use is essential. So these are like medical devices or certain types of protective equipment where the use is important for health and safety, and right now we don't have a good alternative. I would stress that this doesn't mean the chemicals are essential. It's that we have this essential use, and we should be working towards finding alternatives to PFAS and other toxic or persistent chemicals for those uses. And the thing I like about this framework is that we can kind of say, well, let's start with the non-essential ones, because these are the ones we really don't need. And this often is kind of the consumer products that we have in our homes that are a little bit more in our control. So some tips for reducing your exposures to PFAS. We've talked a lot already about private well water testing and filtration. When possible, selecting textiles that don't claim to be water resistant and stain resistant when possible. The FDA has actually changed their policies, and so food packaging, at least paper-based food packaging, isn't supposed to have PFAS in it anymore. So maybe this tip is becoming less important, but we still recommend people eat more fresh foods in general, and try to avoid grease-proof food packaging like microwave popcorn. Selecting other types of dental flosses that aren't based on Teflon. And I mentioned that PFAS and other chemicals can accumulate in dust in our homes. And so there are ways to keep dust levels low, like with air filters or HEPA vacuum cleaners, and that can be a way to reduce exposures as well in the home. We have a great smartphone app called Detox Me for iPhone or Android with lots of tips, not just on PFAS, but other ways that we can avoid toxic chemicals in our daily lives through the app. And then some other thoughts on ways that we can get involved or take action in our communities or as kind of broader residents of the state or the country. So as consumers, we sort of vote with our money, so we can ask questions about the things that we're buying. We can let retailers know that we don't want PFAS to be in the products that we're buying. Vote for people for candidates who are supporting stricter chemical safety testing. Come to events like this, share what you know with other people, your friends and family. One thing I've thought about is procurement policies, which sounds a little boring, but when we're thinking about purchasing things just for our house, it's just like a small quantity, right? But if we're thinking about procurement, this is policies at the town level or maybe in your workplace or school. There's kind of big purchasing power if you think about an institution rather than an individual. And there are 3 cities or towns in Massachusetts that have put in place procurement policies to avoid, when possible, buying, municipally buying products that contain PFAS. And I'm happy to share the language from those bills if that's something that might be of interest here in Nantucket. You can find out about local organizations and state legislation. Unfortunately, not much positive public health news seems to be happening at the federal level right now, but there are things that we can do at the state level. Just last year, the Massachusetts legislature became the first of 2 states to ban PFAS in firefighter gear. And there is legislation now being considered at the state level to ban PFAS in a much broader range of products. So you can become more active and aware at the state or the local level. And then supporting efforts to protect local water quality as well. So with that, I like to put up this picture of my kids being happy with each other because it rarely happens. But they're really the reason I do this work, to protect the next generation. And thanks to the town of Nantucket for funding me to come here tonight.
Well, thank you for that great presentation, Dr. Shader. Happy to take questions. If you want to just come up to the mic, feel free. I do see that we have some questions online. Someone already has their hands up, so I'm going to unmute them. And if anyone else has questions, feel free to raise your hand, and I'll be able to unmute you as well. All right, so Burton Balkin, I'm going to unmute you. Go ahead.
Thank you. Can you hear me?
Yes, we can hear you.
Great. I have two questions. First one is there any plan for the town of Nantucket to reimburse or pay for PFAS for private wells? I heard other towns in the Cape are doing this. And my second question would be, are we trying to figure out where our PFAS that's in our water system is coming from? It sounds like from the doctor, there's a lot of sources, and I don't know if we're testing for where the PFAS is coming from. So thank you very much.
Yeah, I'll take those ones. First question was, are there plans to reimburse? No, we don't have plans at the moment to reimburse. As Dr. Shader mentioned, private wells are typically the responsibility of the private owners. Our health department is available to help think through those decisions, whether or not you need a filter, help you access testing. So we're happy to do that. Second question was, where is it coming from? Nantucket has many high concentrations of PFAS in private wells that currently have no identified source. And if you've been following our Board of Health meetings, I think it was last month, we shared some fingerprinting that we've had one of our consultants do, and they found that over a very short distance, there were at least 2 potential sources in that immediate area. And so they were able to identify 2 different PFAS signatures or fingerprints over the course of, a couple hundred meters. So I think realistically, there are probably many sources on the island. I wouldn't think of it as one connected source because we're seeing it pop up in many new places month to month. All right, and okay, we have someone at the, go ahead.
Is this one on? Yep. Question, I found it really very interesting what you were saying about septic systems. And I'm just wondering if is there anybody doing active research into septic systems and how much it leaches or how much PFAS can be emitted from septic systems? Because especially here with our houses being so close and things, I mean, if you have a neighbor, you can cut back on all the products, you have in your house and go completely PFAS free. But if your neighbor isn't, how much and the water flows that way towards your house or towards your well, and we have a lot of septic systems on this house. So could they unknowingly be contaminating your well, and how much could that be? And so I just found that very interesting. I'm just wondering if there is any studies out there that are looking into that. I mean, how much are these septic systems leaching out, and how much could they be contaminating your neighbor's well or anybody else around you?
This one's perfect for you.
Yeah, thank you. That is a great question. That's not something we're actively working on right now. There are a few studies that I'm aware of in the scientific, other published studies that have tried to measure PFAS in wastewater from septic systems. It certainly can vary from home to home depending on the types of products. So when you think about a wastewater treatment plant pulling from hundreds or thousands of people, the levels are maybe more similar from place to place because you're averaging out over a lot of different homes. Whereas an individual septic system, maybe you're someone who really loves to Scotch guard everything in your house. Maybe you'd have higher levels in your septic system than someone else. So there's going to be more variability with some that might be low and some that might be high. But I think it's a really interesting and a really important question. And certainly on your own property, usually your well is upgradient of your septic system. So if there's impact, it wouldn't be from your own septic system. But certainly where you have private wells, you can look at nitrate as a marker. If you have elevated nitrate, that's coming from somewhere, and sometimes it's from fertilizers, but in many cases it's from septic systems. And I remember in our earlier private well testing where we also looked at artificial sweeteners. This was part of a longer list of things that we tested for, including some pharmaceuticals, some flame retardants. And when we reported back, we had a community meeting with the people in our study. I looked at the results and I was most worried about the PFAS because of what we knew about their toxicity. But there were people there who said, I don't have anything in my house with artificial sweetener in it. We don't buy these things, but we're getting it in our water because our neighbors are. And so that really, I think, crystallized for people that connection that you're talking about.
Are PFAS listed on product labels? You mentioned Oral-B dental floss and microwave popcorn. So those were kind of eye openers. And will you find them on the labels of products?
No. In a word, no.
Okay, so is there a resource that you can go to tell you which products will have it?
It's not an easy answer. So there are some things that some ways you can tell if something might have PFAS in it. So certainly if it says Scotchgard, Stainmaster, Gore-Tex, or Teflon, those contain PFAS. Sometimes things will say it's PFAS free. Those are a little bit few and far between, but increasingly with cookware, you can buy cookware that'll say that it's PFAS free. And there are some resources. For instance, the Green Science Policy Institute has a website called PFAS Central where you can look up certain brands, especially if you're maybe trying to buy a rain jacket or some clothing. They do have resources for certain categories of products and ones. Sadly, I think the list of things that we know doesn't have PFAS is shorter than the list of things that might have PFAS. And I feel like I'm just as much in the dark as anyone else. We were buying some new furniture last year, and I was on the website of the manufacturer trying to see if they said anything about it. It can be really tricky because retailers might say, oh, we have safe C6 technology, and that sounds like it's not PFAS, but what they might actually mean PFAS that have 6 carbons. So it can be really a challenge, and things are really tilted towards sort of industry not disclosing what's in their products rather than disclosure.
So as a follow-up, I'm sorry.
Can you speak into the mic so people at home can hear you?
I know you don't want to recommend products, but do all Oral-B dental flosses have PFAS? And can you tell us which dental floss doesn't have PFAS?
So it's really the Oral-B Glide that is made. It's not coated with Teflon. It is Teflon. It's just, and that's why it's so slippery. So PFAS are really useful because they make things like nonstick, grease resistant. So they make things slippery. So what we've found, and I can send you a link to a paper where we did do some testing of dental floss. That sort of flat ribbony dental floss. There's also generic brands that say on their label compare to Oral-B Glide. So if it's that sort of texture,
Okay.
that's a signal that it's made with Teflon. Anything that's waxed or silk or any other type of dental floss is not likely to be made with Teflon.
All right, I'm going to pass it over to Mary Lepre, and then we've got Enoch online afterwards. So go ahead, Mary.
Thank you. I wanted to say that everybody should watch that continuing medical education. It's awesome. I've watched it. It's amazing. I have sent it to so many people because I really think it's an eye opener. And if you work for the town insurance does cover the PFAS blood test, since they're the largest employer on the island, I think. And then I had a question because we are currently in a town debate about putting in turf or maybe using grass, because that seems, in my mind, I'm a nurse practitioner and mom. I think grass seems safer. It's been around a lot longer and seems to have fewer injuries and less exposure. And I would love to hear your thought, because we did have a scientist who is no longer respected come and speak to us a couple years ago and told us that the crumb rubber, which I know isn't used anymore, was only bad for fish. And she told us that children inhaling pieces of crumb rubber was not a big deal, and whatever infill wood they're using, I can't imagine is good for kids to inhale. But I would love to hear your exposure or your thoughts about turf.
Yeah, well, thanks for the endorsement for our CME course first. And thanks for the question about turf. I know it's a question that comes up in a lot of communities. Yeah, I have a few thoughts about it. I guess I would start by going back to the essential uses framework and thinking about when we're trying to decide if we need to use a product that contains PFAS, is this an essential use? And in the case of turf, which is I sometimes also call plastic grass because that's what it is. So PFAS are added to the blades, the plastic they use to make the blades, because it makes the turf, I think, more durable. It also makes it easier to extrude from the molds where they're making it. So it often contains PFAS. To me, it falls into one of those non-essential uses because we have another thing that we can use, regular grass. And so from that kind of perspective of trying to avoid toxic chemicals, trying to pick more sustainable options, reducing our reliance on plastic, I think artificial turf raises issues from those perspectives. We're here talking about PFAS tonight, so you might wonder, if we have turf that has PFAS in it, how much exposure is there? We could do a lot of studies to try to answer those questions. We don't have a lot of information at this point to know, how much PFAS might you inhale if there's volatile PFAS, or how much might end up in groundwater from the years of, rainwater running over a field. And we don't have that information to really answer those in a really quantitative way. I did read up on this a little bit. I thought there might be questions about it because I know it's an issue and something being considered in the community. And one helpful set of resources that is the Toxic Use Reduction Institute at UMass Lowell. And they had a nice quote there. I don't remember exactly how they said it, but it said, if you're picking a use to eliminate toxic chemicals that you don't, then it kind of becomes unnecessary to do the exposure assessment, because we take a lot of work to really figure out, how much PFAS exposure might you have from a turf field, and how does that compare to other sources of exposure? I guess for me, I would see it as sort of a non-essential use. I don't know if PFAS are necessarily the biggest concern with respect to artificial turf. There are other chemicals in the turf. I think crumb rubber still is used sometimes, at least. There can be other things in the plastic, or they're using recycled tires or whatever is being used. So there are other chemical concerns as well. It is also just a really large amount of plastic, and we're trying to use. I hope people are trying to use less plastic. It's not recyclable. It's just feels pretty unsustainable. So I would push towards really thinking about all the options. Obviously, if you're going to put a lot of toxic herbicides on the grass, that's not that great either. So I think you have to really holistically really think about how you're going to manage the turf. And then you mentioned the sort of the burns, and there's sort of with respect to using the turf. I know there's other reasons why people like the turf, but I think it's in terms of usage, there are some concerns about the heat and the burns when people fall on it. So yeah, that's what I would say. Thanks for your question.
Aisha, hold on. I'm going to pass it over to Enoch because he's had his hand up for a long time. But I'll have you go next. All right, Enoch, you are
muted.
Enoch, I think we can hear you.
My question had to do with state regulation of our public water system, just allowed more water to be pumped out of the aquifer. Is there any basis for the amount of water being pumped out of the aquifer for agricultural irrigation, and can the agricultural wells be monitored for PFAS?
I'm happy to take that one. I would say that if there are agricultural providers that you are curious about what their water looks like, to reach out directly to them. As for the water question, the public water system, I don't think I have an answer for you. It's probably something that could be directed to the water company. All right, Aisha, go ahead.
I just had an answer for, I think, the gentleman who was asking about the microwave popcorn. There's a Danish company, I think it might be the only one in the world. I don't know if you've heard of it, Laurel. Coop Denmark. They supposedly make PFAS-free popcorn. And then the other thing is that I look on labels is anytime it says PTFE, I would avoid it. Perfluoro, polyfluoral, anything like that. Anytime it says stain resistant, you should look at how it does it. And if you drop something on the fabric and it beads up, like a little bead, and it doesn't absorb, that's usually some kind of stain resistant, product used on it. So those are kind of things that I avoid. And then a lot of times, initially I fell for it too. I thought I was being really good by asking about car seats. And I was like, oh, is it PFAS free? And they said, oh yes, it's PFOA free. And I bought it thinking that's what I was asking for. And it ended up being just one chemical and it had all the other ones. It just removed PFOA and had the other chemicals. So I don't know if that helps a little bit. And Green Science Policy has a whole list sometimes. I don't know, you could go on to them. I think a couple of, if you just kind of Google PFAS-free products, a lot of sites now have some lists of at least companies that are trying to remove the PFAS out of it. That's just.
Yeah, thanks for that. I actually learned that in California, they have they passed legislation that says you can't have a label that says PFOA free, because PFOA free just means it doesn't have PFOA. It could have the other 14,000 ones in it. And so it's confusing if you're just learning about PFAS and you're like, oh, great, it doesn't have those PF things in it. Perfect, But so it can be kind of deceptive to just say it doesn't have PFOA. So, so that is a good cautionary tale. And I love the story of the Co-op Denmark. So this was like one of the largest retailers or the largest retailer in Denmark, and one of the kind of CEO type leaders of the company learned about PFAS being in microwave popcorn and causing miscarriages and other reproductive effects. And she said on TV, she was being interviewed, she said, well, we're just gonna stop selling products with PFAS. And then she went back to her office and was like, oh, how are we gonna figure this out? And they took all their microwave popcorn off their shelves the next day, basically. And that by taking them off the shelf, they prompted a company that was able to figure out a way to make PFAS-free microwave popcorn. So I don't know if that would happen in the US, but it, again, like the FDA did say that they no longer allow any PFAS to be added to paper-based food packaging. I don't know why I don't totally believe it. Just because maybe things have changed, but I don't know if, I never buy microwave popcorn. I feel like there would have been more fanfare to say, hey, maybe companies didn't want to admit they used to be using PFAS. So as far as I know, microwave popcorn bags aren't supposed to have PFAS, but I would love for someone to do some testing and validate that.
I just had a suggestion can your slideshow be put on your website, because you have a lot of those QR codes and a lot of good information, and as you explain the quality of this production. If somebody's watching this, they're trying to do a screenshot, whatever it is, that would be a great resource for us, because there's a lot of pieces. And then you can add, you can say, obviously, this tape for this presentation, but it's okay, if the health department, this is where you go and get your tests or whatever, but put it in one place, and that'd be great.
Sure.
Thank you.
Happy to.
Yep, this presentation's been recorded, so it'll be online, and Dr. Shader, if you're okay, we'll include it on our website as well.
Sure.
I'm not saying the present, I'm saying per digital presentation.
Yeah, both the recording and the slides.
At an earlier forum on PFAS, I think I heard that if you have a point of use or a point of entry filter on your house, and we're supposed to maintain those filters and change them out, where do the filters go, which ostensibly are full of PFAS? And I think I heard you take them to the dump, which seems to me to be rather circular.
So I can answer that question. For a POET system, a point of entry system, that needs to be managed professionally so that should not be going in the landfill. But for a point of use filter, the current regulations do allow for that to go into the landfill, and it is a lined landfill with leachate collection. It's probably not ideal, but that is allowable by solid waste regulations at the moment.
Yeah, I think it points to one of the challenges of PFAS is what do you do with it? They don't break down. For the most part, water filters are really about separating the PFAS out. So there's not really a good solution. I mean, this also comes up with what if you get rid of your Teflon pan because you don't want it anymore? What's the right thing to do with that? There's also not really a good thing to do with products either. And I hear you about the concern. You've carefully filtered this PFAS out of the water. It feels not great to put it in the trash. But I don't know, it's at a level that we're worried about at parts per trillion, but it is a very small amount compared to, say, a microwave popcorn bag or, some other items. So I think it points bigger picture to the challenge of creating super persistent chemicals.
Thank you. First of all, thank you, Andrew, and thank you, Doctor, for the presentation. There's a lot of information to take in, a lot of it fairly concerning. I have two questions, if I may. The first one just refers back to what was just asked. In the point of entry systems, it appears as though the RO would be the less desirable because it again would be concentrating chemicals and PFAS, which then would probably exceed what is Title V allowing into a dry well system. So it would seem that point of entry would be that. And in regard to point of entry, is that going to be more effective than point of use because of things like showers or other uses of water other than drinking or cooking? How much of that exposure is still going to create an imbalance of those chemicals? So we're looking at point of entry being the preferred. And then my second question, if I may, is, is there any research or are there any products that are available or are in research that would mitigate, remediate the effects of PFAS in our bodies? Thanks.
Would you like to take those?
Yeah, you can add on to it, but I'll take a first pass. So with respect to point of entry, I think usually RO is at the point of use and not at the point of entry because, again, for every gallon of treated water, you have 3 or 4 gallons of wastewater. So it's really too much for a household level. The home RO systems are, I think, pretty much always at the point of use. So that's where those usually are. In terms of in the amount of concentration that would happen, so when you said something about creating water that had very high levels of PFAS. Again, I should have, we were talking about this a little bit before. So if you have, say, 5 gallons of water that you are putting into your RO system, that will create 1 gallon of treated PFAS-free water and 4 gallons of water where the PFAS are held back. So it is a little bit concentrated, but it's not that much concentrated because you're basically concentrating it by 20% or 25%.
But that would also depend on the amount of concentration of the PFAS in the water, the actual concentration.
Sure. So yes, but as a percentage, it would be, again, because you're sort of having 1 clean gallon and 3 or 4 treated gallons or untreated gallons. It wouldn't double it. It would just increase it by maybe 20 or 25%. And in terms of the amount of exposure from showering or other uses compared to consumption and thinking about that decision about, is this something we want to do at point of use versus for point of entry? In general, it's thought that really the biggest source of exposure is from ingestion, so drinking the water or using it for cooking. There are some PFAS that are volatile. So if you're thinking about in the shower, I guess you do breathe in like a little bit of steam. And for other types of contaminants that can be more airborne, that could be of concern. So I don't know, I think at probably very high levels, if you had high levels in your water, you might want to consider a whole house system. If you have lower levels, my sense is you wouldn't have really high exposures from those other pathways. But I don't know at what point that, that becomes more of a concern. But certainly really focusing on the water that you're drinking and using for food is the priority. In terms of mitigating the effects of PFAS, I'd say that for people who have high levels of PFAS accumulated in their blood and want to do something about that to get their levels down more quickly, there are a couple of things that people have considered, and there are some limited number of clinical trials. So one, there was a study of, I think it was Australian firefighters, where they looked at blood donation or plasma donation, again, because the PFAS bind to proteins in our blood. And so they did show that the firefighters who donated more blood did lower their blood levels more quickly. Another thing that's been considered is a cholesterol lowering medication called cholestyramine. This was actually discovered in the C8 study. So there was this large study in West Virginia of 70,000 people who'd been exposed to PFAS from their drinking water. And the researchers noticed that people who were taking this medication, cholestyramine, it's sort of an older generation cholesterol medication, had very low levels of PFAS in their blood. And so there was a clinical trial, I believe last year in maybe Denmark, that did show that people who were administered cholestyramine were able to lower their blood levels more quickly. And so those are, maybe the doctor, the medical doctor might say more about this. It is something that's being considered. I think there aren't, I know that there's a doctor in Maine who is working with some patients who had very high levels of exposure from sludge being added to agricultural land. And wanting to lower their levels more quickly. So that's what I sort of know about how to lower levels more quickly if you have high levels in your blood. In terms of undoing any past harm from the chemical exposures, I think that's probably trickier to think about. But hopefully that it starts to answer your question.
Can I just add one thing? I would just recommend talking to your doctor if you're considering any of those things.
Yeah, certainly.
Hi, great presentation, thank you. Curious to know if there's any research, you were mentioning airborne contaminants and whether or not there's been any studies done about exhaust and things like that related to airports and communities that might be closer to an airport and how PFAS in those areas might be.
Sure. My sense is that the concern at airports is the use of the firefighting foam for emergency response or for trainings. And I'd say that type of foam is not frequently used. It's used for training periodically. I think the bigger concern is really more the potential for water contamination. My guess is there's not a lot of PFAS sort of accumulating in the air and contributing to people's exposures that way. I think where air emissions are a bigger concern are in areas where there are sort of industrial facilities that are kind of continually emitting PFAS into the air, which can be of concern in terms of inhalation. And it can also be a way that water can be contaminated as well.
Sorry, I'm very passionate about this. Our home was one of the homes that tested positive a long time ago when this all started. And I have young kids, so wondering, is any PFAS exposure safe in your understanding?
I mean, I'd say the more we study, the more we see effects at lower and lower levels of exposure. And so I'm inclined to say there's no safe level of exposure. And when we think about, like I'm not a risk assessment person, but in the risk assessment field, we kind of divide the world into cancer-causing chemicals and chemicals that have other types of effects on people's health. And with respect to carcinogens, it is really thought that there's no safe level of exposure, that as you reduce exposures, that the risk sort of goes down maybe proportionally. And certainly PFOA has been classified as a carcinogen, and PFAS is a possible carcinogen. So from the risk assessment framework, from that perspective, there's no safe exposure. But from what I've seen, the harder we look at lower levels of exposure, we continue to find health effects.
So if you are no longer using, our well was contaminated, so we now have town water. However, since 1986, this well has been pushing water through our house. Does any of that, I haven't tested our sink from the town water, but I don't know if any of that can be in the pipes. Do you guys test family?
That's a really, yeah, that's a.
I didn't know if you tested wells on the Cape after they had gotten clean water.
That is a really great question. We haven't done that type of testing specifically. It probably depends what types of pipes you have. If it's metal, my guess is that there might not be much accumulation in the pipes. If you have plastic, it could. It's possible, I guess, that the PFAS could accumulate and then come off. I don't know that there's anyone kind of looking at that question. I think that's a good question.
I can at least say that Mass DEP, when they sample homes, they'll find high levels in some cases, and they'll test non-detect after they install the treatment.
And just kind of follow up on that, like my wife said, I think I asked this at one of the last PFAS information sessions, but I was always curious about how heat. So like your water tank, how does that, because my understanding is that when you boil water with PFAS in it, it congeals and concentrates. And so how does a hot water tank affect that? And does it build up in there? And it's always been a kind of a curious point in my mind. And I think that would be a very interesting study.
Yeah, so the question about boiling water, the reason why it concentrates is, so if you have a pot and you boil some of the water off, the PFAS stay behind, and then the amount of water gets smaller. And so the concentration is higher after you've boiled some of that water off. I think in a hot water heater, it's raising the temperature, but it's not necessarily, you're not losing water necessarily from that. So I don't know that it would make it more concentrated if you had some PFAS in the water.
Hi, I had a question about one of the presentation, the screen that said the filter, if you used carbon filter for the short chain for the life of the filter, like it would reduce, or it was effective, but maybe not for the life of the filter. So let's say you put in a carbon filter under the sink or a whole home carbon filter. Could you eliminate short chain in the beginning of the filter? And then instead of, if it's like a 6-month filter, could you kind of just say, okay, I'm going to use this and get the short chain out because I'm going to change it every 2 months instead of the 6 months? Is that one way that we could get long chain and short chain out? And then the other question was, I think for like homes where, it doesn't make sense to do reverse osmosis, could you do a carbon or one of the other filters at the beginning of the home and then another one at the point of use? So you've kind of got like a double filter system going on. I don't know, just like carbon over carbon. Just a thought. I don't know.
I think those are great questions. The question about carbon filters over the lifetime of the filter, I don't know as much, I haven't seen as many examples of looking at the lifetime of a filter in people's homes, but what I have seen is, when a town puts in place a carbon filter, what happens? And so my understanding is that, for water systems that put in place basically a 20-ton Brita filter. That's what an activated carbon system is that at the beginning, you see sort of non-detects for all the PFAS. And then the short chain PFAS break through more quickly. So what that means is that they're able to start kind of passing through the filter. And they do that earlier than the long chain. So the long chain eventually will break through also, and that's when it's time to change out the filter. So at a municipal level, I think a solution to short chain would be to change out the filters more often. Right now, they're changing them out, I think in general, to make sure that they're meeting the standards. And so the short chain ones are probably breaking through more quickly. For instance, looking at data from Hyannis. So they have carbon filters. They are non-detect for all the long chain PFAS. But I looked at the UCMR data, so this is nationwide testing, they do have some short chains that are breaking through because they're meeting the regulations. They're doing their job, meeting the regulations. It's not uncommon to have short chain PFAS get through. But my understanding is, yes, if they change them out more frequently, that the short chains would be removed as well. So I think that would work to change it out more often. I do know that there's, depending on the water chemistry, the amount of absorption for the short chain PFAS might vary depending on the other constituents in the water and exactly what the carbon is made from. But I think that would work. I'd love someone to do that study. And in terms of layering multiple carbon filters, I mean, I guess that could be another option as well.
And then I don't know if this would be a question for you or maybe Mark Willett would be, so what kind of filter are we using or will we be putting in well 15? And have we tested for shorter chain?
They are installing ion exchange. We are testing for short chain. Like I know they test for PFBS, PFBA. Those are included in the standard testing methods.
Are we doing like 1033 or do we know, or because I've just seen if it's like the PFAS 6, so I didn't know if that would be really, I think people would want to know, and that would be helpful for us who.
Yeah, what are the main two, Dr. Shea? Is it 533 and 537.1? I don't know which one of those two it is, but it's one of those two.
So with I think in Hyannis, they're changing out the filters to make sure that they're non-detect for all the regulated PFAS. With the timing, would you be monitoring for the short chain and changing out more frequently, even if you were still non-detect for all the long chain?
That'd be a question for the water company. I just want to give you a heads up, we're at time, but you're of course welcome to keep going.
Okay. Thanks for all the great questions. I always.
All right, well, thank you for the great presentation and the great discussion. We will be back here December 11th at 5:30, same time, same place, for Dr. James Todd on a deeper dive into health effects. Thank you, everyone.